Okay, so we are going to deal today with the theoretical part of projectile motion, all the theoretical part with one example. Then 2 days combined, I'll deal the advanced level problem. First, 1 day NEET level problem, 1 day JEE mains level problem, 1 day advanced level problem for the motion in plane. Okay, motion in plane means the relative velocity part and projectile motion part. Okay, so there will be three different lectures to complete still. Okay, so let us move to the theoretical part of it. So we are going to start with like what is called as a projectile. So first thing is there, like if we go through the projectile motion, we can what is the point is over here. Till now we have studied like what we have studied, like either the particle was moving on a straight horizontal path, like here and there, they are going here and there, or idhar udhar kabhi jate the. Either one particle was thrown with some initial velocity along the vertical direction, and it was performing what that the total change means, if this particle has went up to the maximum height, it will drop to the same position, means it will drop down to the same position from where it was thrown. So this was perfectly horizontal motion. Okay, and this was properly vertical motion. But right now we are going to study about a motion in which both of these properties will be combined, and we call this as a projectile motion. Now look over here. Here every trajectory, like how many types of projectile motion can be there. Like I can take one particle, I can have the initial velocity making some kind of angle theta with the horizontal, and also it will have some component along the vertical, and the particle will be thrown like this way. It will cover some kind of range in some time t, and it will also have some kind of maximum height over here, but or not during its total movement. Now another way to throw a projectile is what, just making its horizontal velocity over there, and just making the total vertical initial velocity u vertical to be equal to 0, and having the horizontal component only, and the particle will travel like this way. Now another method is that, like let's suppose if I took an height of the tower, I try to throw one particular particle, I took one particle at the height of tower, and then what I'm doing, I'm just making it move, or I'm making initial velocity for this particle making angle theta over here also, neither it properly along the horizontal, neither properly along the vertical. So that means what is going to happen over here, first this particle will follow like this kind of trajectory, got it or not. Third case is what, I can make the initial velocity from the height of tower properly pointing downwards, and we will try to write the time equations, we will try to write the height equations, we will try to find this range of the projectiles when it is going to follow this kind of path. Second, and like these are the normal, see this one is the given in every kind of book, this projectile 1, projectile 2 is given in every book, projectile 3 is not given, projectile 4 is not given, projectile 5. Now look over here, what we can do, we can take one inclined plane making angle theta with the horizontal, and we can also throw a projectile making angle alpha with the horizontal. Now at this case, this projectile will hit somewhere at this point on the inclined plane, and we'll have to calculate the range, like at what distance on the inclined plane this projectile is hitting. So this kind of problems, this kind of cases of projectile, we all, like all of these cases we are going to discuss one by one. All of these we will write the equation of motion for all of these cases. But one thing you will have to do, that you will have to write at least time of flight, at least time equations for all of these cases. Are you able to get me or not? So how many cases of projectile we are going to study? 6 cases of projectile we are going to study. Are you able to get me? Yes or no? Okay. Hmm. So let us start. Okay. Before going to that, first we'll try to write the equation of motion for the projectile in vector form. Okay. Now this is totally different from what you have studied. As you know that equations of motions are what? Look over here. First, v is equal to u plus at. This is my fundamental equation of motion. Second equation is s is equal to ut plus half at square. Third equation is what? V square is equal to u square plus 2as. Now, for this particular projectile, what we are going to do is we are going to write this whole equation of motion in terms of velocity components and some different kinds of acceleration components. So now look over here. Perfectly try to look over here. So this initial velocity has two components. One, u cos alpha along the horizontal. Another, vertical component, okay, u sine alpha along the vertical. So now I can write the initial velocity equation. I am writing which equation? Initial velocity equation. Remember that. What I am writing? Initial velocity equation, that I can write it as u cos alpha I cap plus u sine alpha j cap. Okay, now look over here, try to understand this. What is present? Now we know that acceleration along the horizontal is how much? Zero. Acceleration in vertical that is present, that is equal to minus g. So acceleration along the vertical is going to be how much? Minus of g j cap. Now let's suppose this projectile comes over here, okay, and I want to calculate that what is the let's suppose if the projectile is coming over here, I want to know that what is this final velocity vector at point P. Means I want to write the velocity vector at point P. Now you know, now look over here, this velocity vector at point P will be what? It is going to have some kind of velocity vector, initial velocity, like a final velocity at point P along the I cap direction. So I'll write this as, let's suppose this particular velocity vector is making some kind of angle alpha with the horizontal. Okay, so this angle is what, guys? Angle alpha with the horizontal. I can write this as V of P cos alpha I cap plus V of P sin alpha j cap. Now this V of P cos alpha, directly it can be written as, you know that during the projectile motion one thing is very much constant, and that is the horizontal velocity, because force in the horizontal is how much? Zero. So acceleration in the horizontal is zero, and therefore there is nothing, no physical quantity which can change, or physical substance is there which can change the velocity of the horizontal. So therefore Vp cos alpha is nothing but it is equal to what? It is equal to u cos alpha I cap, and I can write this as velocity of P. Okay, call this as alpha prime, guys. This is different angle. Okay, now look over here. Plus, but sine component, what is going to happen? Since the particle has traveled from here to here in some time t, some velocity along the vertical would have got reduced. Why it would have got reduced? Because we know that what is present in the vertical direction? There is an acceleration and there is a retardation which is present in the vertical direction. So now look over here. What will be the velocity along y equation? That will be equal to Vp sine alpha, and that is nothing but it is equal to what, guys? Velocity wait yeah, u sine alpha, which is my initial velocity along the vertical direction, minus there is an vertical retardation component, so minus of g of t. So I can write this as u sine alpha minus g of t j cap, and which you are aware of it. So this is my whole velocity equation for the projectile, which the projectile is following when it is traveling along the y-axis and x-axis, where it is not said that any of the axes is representing any property or not. Okay, so are you able to get me or not? Okay, it is too much easy. Guys, we have done this, yes or no? So this is kind of easy, perfectly easy for you guys. Ankit, Afan, Nizan, Parinita, Radha, Sanjana, Sneha, Sparsa, Hitesh. Yes or no? Okay, now I will try to do little bit more on this. Now, till this we calculated, but as you know that we are aware of this velocity, so can we calculate the particular displacement of the particle from here to here or not? Now this displacement will be something else. Now look, what will be this displacement? This displacement will be a line, a straight line joining from here to here. So in class what I did when I was dealing with the relative velocity, previously I didn't dealt with this displacement factor. Now here I am going to deal, because if I write that equation in the class, the people would have died. So now look over here. Displacement is what? It is equal to ut plus half at square. Now, what is u over here? You know that u is given u cos alpha. See this, how much big is this equation going to be? U cos alpha into time t I cap. Wait, I'll write u cos alpha I cap plus u sin alpha j cap in or multiply with time into j cap plus half. Acceleration is what? minus of G J cap into what? T square. So what you got as a relation? You got the relation as U T cos alpha I cap minus half of, or you can, what you can do, you can just take this as, you can write this as U sin alpha into time t, okay, minus half of gt square j cap, and that is your displacement vector for the particle which is following this projectile motion. Are you able to get me or not? So this is what displacement vector equation for the particle which is following the projectile motion. Are you able to get me or not, everyone? Yes or no? Guys, are you able to understand this? Easy. Just I'm using the vectors to write the equation. I'm just using the formulas which were written initially. I'm just utilizing that. Okay. Now based upon this, as we are aware of the displacement now, we'll try to do some problems based upon this. So let us take an example one. What is that? A particle is projected with velocity of 50 meter per second at 37 degree with the horizontal. Find the velocity, displacement and the coordinates of the particle with respect to the starting point after 2 seconds. Can you do it? Try to do it. 2 to 3 minutes time for this. Can you do it? Just try to do it, guys. What it is saying, I'll draw the diagrams. Okay. A particular projectile is there. This is, let's suppose, I'm not calling it x-axis j cap. This is I cap. Vector form we are utilizing. A projectile has been thrown. Okay. A projectile is there whose initial velocity is how much, guys? Initial velocity is also mentioned, and the initial velocity is equal to 50 meter per second at 37 degree. Okay, so already I told in class that I will utilize 37 and 53 so that you can remember in your exams perfectly. What it is asking? It is asking find the velocity and the coordinates of the particle with respect to the starting point after 2 seconds. So velocity after 2 seconds it is asking, simple. So look over it. I can write the initial velocity equation. Initial velocity will be what? 50. First draw that triangle. This is 3, 4, 5. This is 37. Okay. So u is equal to 50 cos 37 I cap plus 50 sin 37 j cap. Now look over it. What it is going to be? Cos 37 is what? Base by perpendicular. So 4 by 5. So 40 I cap plus 50 into 3 by 5. Okay, so it will be 30 j cap. So you got your initial velocity equation, that is equal to 40 I cap plus 30 j cap. Now it is asking what the velocity after 2 seconds. So now look over here. Final velocity equation is what? U cos alpha, simple, U cos alpha I cap plus U sin alpha minus of gt j cap. So that means what? U cos alpha you have calculated, that is 40 I cap plus 30 minus g. G is what? 10. After time how much? 2 seconds. So 2 j cap, that is my velocity vector. So velocity is going to be how much? 40 I cap plus 10 j cap. This is your final velocity equation. Are you able to get me or not? Tell me yes or no. So what it has asked? It has asked the velocity of the particle. Find the velocity and displacement and coordinates of the particle after 2 seconds. So did you got the velocity after 2 seconds? Yes or no? Are yes or no? It is. Did you got? Yes, Radha, Sneha, Sanjana, Parinita, Nishan, Afan, Ankit, got it or not? Hmm? Hmm. Are you able to understand this? Yes or no? Okay. Now look over here. Moving to next point. Okay. Just 1 minute. Try to calculate the displacement. हितेश निकल गया डिस्प्लेसमेंट. डिस्प्लेसमेंट इक्वेशन क्या है? लुक ओवर हियर. ut cos alpha I cap, ut cos alpha I cap, मैं तो ऐसे ही लिख दूंगा भाई, प्लस ut sin alpha minus half of gt square, I think gt square ही है, gt square j cap. ये है तुम्हारे पास इक्वेशन है ना? Worded or not? I think there is a plus sign over here. Okay. So now look over here. So this is going to be how much? U cos alpha, you know, that is 40. Time is how much? 2 I cap plus U sin alpha, you know, that is 30. Time is 2 minus half of 10 into 2 square. 2 square means 2 into 2 got cancelled, j cap. So what you got as a displacement? 80 I cap plus 3 2s are 6, 60 minus 20, that is 40. So 40 j cap. So you got the equation of displacement, or displacement vector as what? 80 I cap plus 40 j cap. Now look over here. As you know that this displacement vector, now look over here, try to understand this. This particular point, if someone asks you that what is the coordinate of this particular point, if someone really asks you what is the coordinate of this particular point, what will be your answer? Simple. As you know the displacement vector, this is saying what? This displacement has some x component over here, and you got the y component also from the j cap. Okay. So this means what? You are already aware of x distance, that is equal to how much? Ut cos alpha. You are aware of y distance, that is equal to what? U sin alpha t minus half dt square. So this distance, this particular distance of this particular point has how much value? Ut cos alpha, and this value has, this has how much value? U sin alpha into time t minus half gt square. So when you are aware of these two values like ut cos alpha and this value, so you are aware of the coordinates. So now look over here, as comparing over here, what is the value of ut cos alpha? 80. What is the value of ut sin alpha minus half gt square? That is 40. So now if someone asks you what is the coordinate of the particle after 2 seconds, so what is that? That is equal to 80 comma 40. Simple. Yes or no? Are you able to get me or not? Guys, yes or no? Got it? Sanjana? Sleeping? Sneha? Radha? Parinita? Got it or not? Nisant? Ankit? Hitesh? Okay. Hitesh? Are you there or not? Hitesh? Hitesh हो गया. Hitesh? Ankit? Hey Ankit? Hitesh हो गया है ना? मैं बताता हूँ उसको. Okay, now moving to next point. Okay, so can I move to next question? This was the easiest question of this part. Moving to next question. What is the question? A particle is projected with velocity u at angle theta with the horizontal. Find the time when the velocity vector is perpendicular to initial velocity vector. Wow, what a question. Think about this question. 100 rupees, okay, 500 rupees coupon means 500 rupees prize money, those who will solve this question. Hitesh, कहाँ हो? इसको बताता हूँ मैं. Solve this question. This is X, this is Y. I'm feeling so sleepy. The projectile is not nice. Solve this question, solve this. Think about this question. It's not a that much simple question. You can solve easily. Okay. This is a good projectile. Yes. Okay, so I thrown one projectile with some initial velocity. Okay, this is my initial velocity direction. Right or not? I have thrown some projectile with initial velocity u. What it is saying, you have to calculate the time. Let's suppose at some point p over here. Okay, or let's suppose at some point p over here, the velocity vector. This velocity vector. This is the velocity over here or not? Yes or no? This is my final velocity over here. Okay. So this velocity vector is what it is saying, that velocity vector is making how much angle with the initial velocity vector? It is making 90 degree over here. This angle between them, this particular angle. This angle is how much? 90 degree. Got it or not? So you have to calculate the time period, means what is the time elapsed during from here to here, when the particle has came from here to here. I made you understand. Try to think and solve. This angle is theta given over here. Any idea? इधर तुम्हारी आवाज नहीं आ रही यार. Let me call that guy. अंकित बना. हितेश. Try everyone fast. Should I solve? If I solve, you will be like, sir, what you are doing, sir? You have made fun of physics. Should I solve or not? Let me solve, because you guys are hell. Look over here, see this. Okay, if things are perpendicular, what is the relation? What is, like, you know that if two vectors, this is initial velocity vector, this is final velocity vector. If they are perpendicular, then what is going to happen? U dot V. U into, again into, it is dot, U dot V is how much? It is equal to 0. First thing, these two are vector quantities. If the particular things are perpendicular, the dot product will be 0. Now you know that initial velocity equation is what? It is equal to u cos alpha I cap plus u sin alpha j cap. Final velocity vector is what? It is equal to u cos alpha I cap plus u sin alpha minus gt j cap. Take the dot product of all of these things. U cos alpha I cap plus u sin alpha j cap dot u cos alpha I cap. Sorry. U cos alpha I cap plus u sin alpha minus gt j cap is equal to what? 0. If you do this, you will get one relation, u square cos square alpha plus u sin alpha into u sine alpha minus zt, and that is equal to what, guys? It is equal to 0. Yes or no? So okay, so here it actually, so consider alpha is equal to theta. Okay, so therefore we can utilize the relation. So u square cos square alpha plus u square sin square alpha minus u sin alpha into gt is going to be equal to how much? 0. Now u square cos square alpha plus u square sin square alpha. I can take u square common. Cos square sin square is what? 1. That is u square minus u sin alpha into gt is equal to what? 0. So what you got as your time? Time is nothing but it is equal to u by gt sine alpha. So what is your time? After what time the particles will have the perpendicular velocity component is, okay, sorry, sine alpha, sorry. Yes, sir. U by g sine alpha is the time after which the particles are going to have, like, the velocity is going to make perpendicular, or velocity is going to get perpendicular with respect to the final velocity or some velocity at some point. Got it or not? Yes or no? Are you able to get me or not? Got it? Yes or no? So these are most easiest kind of questions, but most toughest kind of question based upon how you are perceiving it. Got it? If you perceive in a different way, these are the most baddest question. If you perceive in a good way, then you can solve all these kind of questions. Okay. So remember this always. Whenever you will get some kind this kind of equations, no, like when it is making perpendicular, when it is making something like that, you try to do it in this way. Okay. Now, moving to next topic. Okay, so now we will have the type 2 of the projectile motion. Okay, now as the type 2 we are perceiving, type 2 means we have first the normal case, like the particle is thrown with some making angle theta with the horizontal. Now in second case, the particle is making some kind of angle alpha with the inclined plane, and also the inclined plane is making some angle beta with the horizontal. So actually the particle is thrown at the particle, let's suppose someone asks you, the particle is thrown at how much angle? Alpha plus beta from the horizontal in second case. Got it or not? So two cases are there. First case is what? Tomorrow. Tomorrow is Wednesday. So second POC is 10, 15 to 11. Wednesday. Tomorrow I have 2 to 3:30 class. Huh? Okay. So particle is thrown at alpha plus beta from horizontal. Now you try to understand what is going to happen. So along the x-axis, the equations of motion will change as what? Vx is equal to ux plus I, something like all the variables of equations of motions are going to have the x component. Let's suppose if you talk about the movement along the x component, what is going to happen? The equations will be always considered along the x component. If you talk about the movement along the y-axis, the equations of motions are going to change with respect to the y-axis. Got it or not? So now look over here. If we try to see along this all of these things, what I observe that in this case, u cos theta is along the horizontal, u sin theta is along the vertical. Simple. Now the acceleration along the horizontal is how much? 0, while the acceleration along the vertical is equal to how much? Minus. But what about this case? What about this case is going to happen? Okay, now this is little bit very difficult, trivial. What is going to happen that the particle has some initial velocity along the inclined plane, and that is equal to how much? I'll draw this. Wait. So this is my initial velocity along the inclined plane, and that is how much? It is equal to u cos alpha. While this initial velocity is making some kind of perpendicular, like with respect to the inclined plane, it has some kind of, what kind of velocity? Perpendicular velocity, that is equal to u sine alpha. Now, as you are aware that acceleration is acting along the vertical, the acceleration due to gravity is acting along the vertical. So, 1 minute, guys. So, What is the concept over here? Acceleration is purely acting along the vertical, but the initial velocities are acting along the horizontal, and the like it is making some kind of angle alpha with the horizontal, and it is making also some angle with the vertical. So in that case, can I use the acceleration minus g in the equations of motion? Tell me. The equation is simple. Can you use a is equal to minus z in these equations of motion if you get the u cos alpha and u sin alpha? Can you utilize it, guys? Tell me. हितेश, अंकित, यूज कर सकते हैं क्या? अफान, निशान, परिणीता, राधा, कैन वी यूज? संजना, स्नेहा? Mm-hmm. The question is why? Because we know that, try to understand, these all are vector equation of motion. What is the first important concept? First important concept is these are vector equations of motion. Here, this velocity, this initial velocity, this acceleration, all are acting in similar direction. Here displacement, initial velocity, acceleration, all are happening in same direction. Here final velocity, initial velocity, acceleration, displacement, all are happening in similar direction. So here, as the acceleration is in vertical direction, none of the component of initial velocity is perfectly vertical, neither perfectly horizontal. So we can't apply the theorem of projectile motion or the theorem of these using the simple convention. So since acceleration is a vector quantity, I will have to first resolve it. I will have to make or consider two components, one along the direction of the horizontal initial speed or inclined initial speed, and one along the perpendicularly inclined initial speed. So that is why what we are doing, this acceleration which is acting along the vertical, which has value how much? Minus of g, which has value how much, guys? Minus of g. We are resolving it into two components, one perpendicular to the inclined plane, okay, and that is equal to, let's suppose if this is angle beta, remember that, try to understand this, guys, try to properly understand this. I'll solve it. Okay, look over here, try to understand. If this angle is theta, okay, and I have something like this way, I can draw something like this way, I can draw something like this way. Remember that, remember that this particular value, this particular, this is angle theta, this angle is also going to be theta. You can ask me how, sir? So this angle is what? Theta over here. Now these are perpendicular or not? So this become 90 minus theta, and since this and these are also perpendicular, so this becomes how much? Theta. So here try to understand, as I maximize it, if acceleration is there and inclination of the particular inclined plane as at angle beta, so this angle will be how much? Beta. And here perpendicular to the inclined plane, you will have the acceleration component as a cos beta, while along the inclined plane you will have the particular acceleration component, and that is going to be equal to how much? A sine beta. Got or not? What is this value going to be? A sine beta. Now look over here. Previously here there was no acceleration along the horizontal component, but here we have the acceleration also along the horizontal initial velocity and also along the vertical initial velocity. So now look over here. That's what I am writing. Acceleration along the horizontal initial velocity, since it is opposite to the direction of initial velocity, it is equal to minus g sine beta. Also, since the particle has upward initial velocity and acceleration is acting in the opposite direction, that is equal to minus g cos beta. Are you able to get me or not? Yes or no, everyone? Guys, are you able to understand me? Sir, but why they have given us plus g? Where? Oh, oh. Minus g is given everywhere. Here, here, actually the magnitude of acceleration is what? G. This arrow direction, this minus is showing or not? Tell me, sir. Are you able to get me or not? Okay. अंकित, समझ में आ रही है कि नहीं आ रही है बात? कहाँ गया अंकित? भाग गया क्या? जिंदा हो ना? हितेश कहाँ गया? निशांत, परिणीता, राधा, ओके, अफान समझ में आ रहा है, स्नेहा, संजना, ओके ओके, मूविंग टू नेक्स्ट पॉइंट, ओके चलो आगे बढ़ते हैं. So we are going to utilize this question and we will try to solve some question, and the question is this, okay. A projectile is fired horizontally with a velocity of 98 meter per second from the top of hill 490 meters high. Okay. Find the time taken by projectile to reach the ground, distance of the point where the particle hits the ground from the foot of hill, and the velocity with which the projectile hits the ground. Wow, what a question. दो तीन चीज एक्स्ट्रा पूछ दिया है इसमें, अच्छा क्वेश्चन दिया है. So this is, let's suppose I am considering a projectile which is hitting, like you have the height of the tower. Projectile is fired horizontally with a velocity of 98 meter per second from the top of hill 490 meter high. So height is given, that is equal to how much? 490 meters. From here I'm throwing one projectile with having the initial horizontal speed, and that is equal to how much, guys? That is equal to 98 meter per second. Now this is x, this is y. Projectile is going to follow which path? You know that if it is a perfectly horizontal path, the particle will hit over here. Okay. Now the question is what it is asking. It is asking the time taken by the projectile to reach the ground. Second, the distance of the point where the particle hits the ground. So you have to calculate first time, then the distance of the projectile. Like this distance you have to calculate. This x distance you have to calculate, and it is asking the velocity with which the particle projectile hits the ground. Okay, so now look over here at this point. If I take the velocity vector, if I draw the velocity vector, it is having two components, yes or no? It is having two components like this way. Okay, this is the velocity vector over here. Now it is making two particular components, one inward of the ground, that is equal to v. Okay, let's suppose this angle is made as beta or alpha or theta, whatever it is. So v sine theta, and along the horizontal it has one more component, and that I'm representing as v cos theta. So you have to calculate that with what velocity the particular projectile is hitting the ground. I have drawn all the things and it is your work to do. Do it fast. Can you solve it? Now look over here. This question is very easy. You are aware of y displacement. You have to calculate the time of flight. So now look over here. You are aware of the vertical displacement, yes or no? So you can write the equation Sy as is equal to what? U of y into time t minus half of zt square. Now, since the particle has initial horizontal speed, initial vertical speed is how much? U of y is going to be equal to how much? 0. So what is the displacement along the vertical? That is equal to 490 meters. Initial speed is 0 minus half of, now this is a downward displacement, so minus of 490 meter minus of half g10 into t square. Now look over here, what is the time you calculated? That is equal to root over 2 into 490 divided by 10, that is 0 0 cancel, and what you got as time? Time is equal to 7 root 2 seconds. Yes or no? That is simple or not? Time is what? 7 root 2 seconds. That will be approximately 9.4 or something like that. Yes or no? Got it or not? Hello? Are you able to get me or not? Yes or no? Okay. Now, based upon this, we can try to calculate, try to understand. Look over here. We have to calculate the distance of the point where the projectile hits. So x distance we have to calculate. X distance is simple. Now x is going to be what? The velocity along the x direction, u of x, and time t. Now u of x you are aware 98. So 98 into 7 root 2 meters. Simple. 98 into 7. I think that will be how much? You do the calculation. That is on your way. You have to do the calculation. What it is asking actually, the most important thing it is, you have to calculate the velocity of the projectile when the projectile hits the ground. This is the most important calculation part. Okay. So how much that should be? Tell me. How to do it? So try to understand. If I say, if you are aware of velocity along x, if you are aware of velocity along y, you are aware of this velocity or not. You are aware of resultant velocity. That resultant velocity is going to be how much? Root over vx square plus vy square. If you are aware of Vx, if you are aware of Vy, then you can calculate the resultant velocity. Resultant velocity direction is what? Towards the ground. This particle is hitting with this resultant velocity along the ground. So if you are aware of Vx, if you are aware of Vy, you can calculate the resultant velocity with which the particle is hitting the ground. Now, how much that should be equal to? How to calculate Vx and Vy? Simple, logical, easy peasy. Saga laga, boom boom, go over here, Vx. So Vy, first I'll calculate Vx. Okay, let us calculate Vx. So what is the final velocity equation? Final velocity is equal to initial velocity along x direction plus acceleration along x direction into time t. Now, final velocity into x direction, that is equal to what? Initial velocity along x direction is how much? 98 meter per second. Okay. The point is, there is no acceleration along horizontal direction. Is there any kind of acceleration along horizontal direction? No, because there is no engine or force along the horizontal direction. So this component becomes how much? 0. So therefore, final velocity along the horizontal still remains same. That is equal to 98 meter per second. First important thing. Second important thing is what? You have to calculate the final velocity, like final velocity along y direction. Now you are calculating the final velocity along the downward part, so it will become what? Minus of Vy, yes or no? And that is equal to what? Now, since the particle, we are trying to show the initial velocity downward, so that will be minus of u into y, and that is equal to what? Minus of, like you try to understand, that is minus of g into time t, yes or no? Now, why minus of g? Because the particle is following downward path. Now look over here. Initial velocity along the vertical path is how much? 0. So v of y is what? Minus minus got cancelled, and v of y is what? Is equal to zt. Now what is the value of g? 10. What is the value of time? 7 root 2. So are you aware of velocity along the y direction? So with which velocity the particle is hitting the ground? That is equal to 98 whole square plus 70 root 2 whole square, and if you do this you might get the value to be equal to how much I will get. You just try to calculate and you will get this value, yes or no? So with this velocity the particle is hitting towards the ground. The question is how much angle it is making with the horizontal when the particle is hitting the ground. You can calculate simply. Now apply the tan theta form. Tan theta I can write it as what? V of y divided by v of x. Now v of y you are aware, 70 root 2 divided by 98, and that is equal to tan theta. If you apply this, you are aware of with what angle this particular projectile makes with the ground if it hits the what thing? If it hits the ground. Are you able to get me or not? Are you able to understand these things? Yes or no? Nishant, Ankit, Parinita, Radha. T is equal to 10 seconds? Then you can get, then definitely you'll get 10 seconds. Yes. Right or not? Yes, sir. Yeah, so it's simple. Okay. So are you able to get me? If someone asks you that what is the velocity if the particle hits the ground, do not get confused. Find the y component of velocity, find the x component of the velocity, and take the resultant of that velocity. This is the velocity with which the projectile hits the ground. Right or not? In normal cases also, in normal cases, let's suppose if I consider this kind of movement of projectile, if someone asks you that with what velocity projectile is hitting the ground, so what is going to happen? Find the time of flight, calculate the time of flight. Okay, your horizontal velocity component remains same. Vertical velocity component will be what? Vy is equal to be u sine alpha minus of zt. If you apply this form, what you will get? You will get the vertical velocity component. Calculate this velocity, that is equal to root over u cos square and something like that. Are you able to get me or not? Yes or no? Guys, easy or not? Okay. Now moving to next thing. Let me see what are the topics left there. How much is the time? 9:12. Still we have time. Okay. Easy question. Okay. See this. All of these things are there. Still. Okay. Okay. Let us do this question. Last question. A body is thrown horizontally from top of tower and strikes the ground after 3 seconds at an angle of 45 degrees with the horizontal. Find the height of the tower and the speed with which the body was projected. Now this is something which you guys not expected. Something different is given. Something different. Things are given. Different variables are given. And that's why my questions are tough in your exams, because I didn't give the direct questions. Yes or no? I twist the questions, and that is why you'll have to attempt in a good way. And do not share your question papers with anyone. Okay? Because those are my best collected questions. Those papers will be available on internet after some time, and the test series I will charge about 5,000 rupees. Got it or not? हितेश सो गया है ना? I'll kill you. I will kill you. Hitesh. Can you solve this question? Try this. It's a good question. Okay. Just imagination is required in these kind of cases. So there is a projectile y-axis, x-axis. So a particular body is there which is thrown from the top of tower and strikes the ground after 3 seconds at an angle of 45 degrees with the horizontal. Now this is a really amazing question. You can think. You have to think. Okay. Find the height of the tower and the speed with which the body was projected. Now look here. When the particle will be thrown from the height of horizontally, it has told. So I thrown this particular ball with horizontal initial speed u. Now, what is happening after 3 seconds means the time of flight along this is how much? 3 seconds. Time of flight along horizontal is how much? 3 seconds. So after 3 seconds, what is happening? The particular particle is making 45 degree with the horizontal. Now, what is 45 degree with the horizontal? So after 3 seconds it is saying or not. So that means what? Your resultant velocity. See, the particle hits the ground after 3 seconds, and here the resultant velocity is making how much degree with the horizontal? It is making 45 degree with the horizontal. Now you know that, let's suppose this my resultant velocity is v. Okay, so it will have two component, one along the horizontal. Okay, this v resultant velocity is going to have two component, one along the horizontal, that will be written as what? V cos alpha, sorry, V cos 45, and one along the vertical, and that is equal to u, sorry, V sin 45. Simple, yes or no? Now, if you are aware of what is the velocity, if you are aware of time of traveling, you can calculate the displacement easily. Why? Because you know that simple rule is there that in a vertical direction, initial velocity is uy is given 0 because there is no vertical component. So uy is equal to how much? 0. And acceleration along vertical is given, that is equal to minus c. So simple, s is equal to what? Ut minus half of zt square. So this is going to be how much? Displacement along the vertical direction, that will be along the downward path. So minus of h is going to be how much? It is going to be equal to minus of half 10 into time of traveling is how much? 3 seconds. So 3s square, simple, yes or no? So height is going to be how much? 90 divided by 2, that is equal to 45 meters. So what is the height of the tower? It is equal to 45 meters. Are you able to get me or not? Yes or no? Radha, Hitesh, Ankit, समझ में आ रहा है ना? Sanjana, Sneha, clear? Okay. Sneha is here or not? Sneha? Sneha also went. Sneha, Sanjana, hello? Okay. You are alive, Sanjana? Okay. Now look over here. So height of the tower is how much? 45 meter, because you are aware of the velocity along initial velocity. Simple, yaar. These things are very, very simple. You have to think logically and fast. Be fast like me. Okay. Now next thing, you know that the resultant velocity is making 45 degree with the horizontal. Previously only I told that what you observe, that the final velocity component is equal to the in the horizontal direction. Like try to see if the initial velocity is u over here. If this is thrown at angle theta, the initial horizontal velocity will be how much? U cos theta. And here, let's suppose the particle hits the ground at some kind of angle alpha, making with the horizontal. So here we will have one component V cos alpha. Now what is going to be the fact that since there is no force along the horizontal direction, U cos theta should be equal to V cos alpha. Simple or general rule, you can say that this is the general rule. So now look over here, if this is the general rule, so now look over here, what is going to happen? This initial horizontal velocity should be equal to V cos 45 degree or not? So initial horizontal velocity should be equal to what? V cos 45. But you need to calculate this V first, yes or no? So how to proceed to that? Easy. How it is easy? Think. Can we calculate velocity along the y direction? Velocity along y direction is going to be what? U along y plus acceleration along y into time t. U along y is how much? 0. Acceleration along y is what? Minus of g. And velocity along y, if I take it to be negative, because in downward path it is, so this will become as positive. Now, time of traveling is how much? 3 seconds. So therefore, velocity along y is how much? 10 into 3, which is equal to 30 meter per second. Now look over here, how much easy is this question? You guys are just getting confused because you are not solving any kind of problem. Okay. Now if you are aware of all of these kind of things, what you can do? Okay, what you can do over here? Simply, you can calculate your velocity along x. How to calculate? I will not use this formula. I'll use the simple formula, most simplest general formula. What is that? Look over here. अंकित, निशांत, राधा, समझ में आ रहा है ना? यहीं पे हो तुम लोग? ठीक है ना? तो ठीक है, मेरी क्लासेस थोड़ी बहुत बोरिंग हो जाएंगी कभी कभी, मैं थोड़ा फास्ट पढ़ाने का कोशिश करूंगा। मैं चाहता हूँ कि तुम लोग बहुत कुछ सीख लो थोड़े से टाइम में, तो उसके लिए बुरा नहीं मानना, ठीक है ना? क्योंकि मैं अभी मजाक मस्ती में पढ़ाने वाला नहीं हूँ। मतलब थोड़ा हमारे पास टाइम कम मिल रहा है ना, इसलिए थोड़ा सा मैं चाह रहा हूँ कि थोड़ा फास्ट कंप्लीट हो, है ना चीजें। So now look over here. As you got the velocity along the y direction, that is equal to how much? 30 meter per second. You can calculate the velocity along x direction as what? I can apply this formula. I can create one right angle triangle. I can apply tan 45 is nothing but velocity along y direction divided by velocity along x direction. So velocity along x I can get, that is equal to what? V of y divided by tan 45. Now tan 45 is how much? 1. So velocity along x is how much? It is equal to velocity along y. What is velocity along y? 30 meter per second. So velocity along x is how much? 30 meter per second. So resultant velocity is how much? With which the particle is hitting the ground? It is equal to root over 30 square plus 30 square. That is equal to 9, 9, 18. 18 I think that is equal to 1800 meter per second. Yes or no? I think I am correct. Yes or no? Guys? Now, if you are aware of velocity v, if you are now try to see, you are aware of Vx. Vx is what? It is actually equal to V cos 45. So if you are aware of Vx, that is equal to how much? 30 meter per second. From here also you can calculate velocity V. That is equal to how much? 30 root 2 meter per second. Here also if you get, see this, I can take 30 common and it will become 2. 1 plus 1, 2. That's why velocity resultant, I can also write it as 30 root 2. Next thing is that if you are aware of Vx, this should be actually my initial velocity or not. As I said, that initial velocity is nothing but it is equal to x component of the velocity which is made by the projectile after hitting the ground, and that is equal to v cos 45 degree, and that is equal to how much? 30 meter per second. So therefore initial velocity, with what initial velocity the particle is projected? It is projected with 30 meter per second. What is the height of the tower? It is equal to 45 meter. Got it or not? Yes or no? Okay. So these were the best questions of projectile which you will never find in any kind of book. I have done this, I have typed this, written this, and then we have done. Okay. So please try to understand, try to get through the questions. Next, like whatever we have done yesterday, tomorrow I'll do a little bit of revision. Okay, time of flight, range, and maximum height, so that again you can understand in a better way. And then I'll write the equation of trajectory for different cases, and then this inclined plane projectile motion, like these kind of questions which we will do, and then the two cases relative motion between two projectile again we will do using animation and all, and we'll complete sub question. Okay, and based upon this we'll solve a whole bunch of 50 to 60 projectile and relative velocity problems. Got it or not? Yes or no? Okay, tomorrow again we are going to meet. Let us meet tomorrow. Okay, तब तक के लिए बाय बाय. हाँ, tell me राधा.